Thank you, Amy. This panel looks at energy technology and innovation. And in particular, over the next hour, or maybe we're chopped down a little bit from an hour, we're going to look at the issue of how do we best move game-changing technologies from the research laboratory and into the marketplace. At MITI, the MIT Energy Initiative, we're all about transforming the world's energy systems. And to do that, it's obviously essential that you get this technology out of the lab and into the marketplace. So we spend a lot of time thinking about how to do that. In order to get technology to the marketplace, we have to link research together with development and deployment. We also have to link back to the marketplace. That is, we need to think in advance about what are the markets out there that can employ the research that we've done. We also have to work across different sectors. We need to work with government, universities, industry, and with foundations. And I think it's great that we have on the panel today outstanding representatives from each one of those four sectors to give perspectives from those different points of view. From government, we're delighted to have Cheryl Martin. She's Deputy Director of ARPA-E, which is, I think by any measure, an outstandingly successful organization that DOE has stood up, which aims specifically at how to do early stage funding to get high impact ideas moved forward towards the marketplace when they're too early for private funding. As part of her role in ARPA-E, she leads the Technology to Market program, which helps move this breakthrough energy technology to the marketplace. And this morning, she's going to give us an overview of how that process works. So Cheryl, thank you for being here with us. As technologies make their way into the market, they inevitably face a variety of barriers, and C3E Ambassador Marilyn Brown is here today to give us some perspective on U.S. policy and regulatory barriers that sometimes impede that movement. Marilyn is a professor in the School of Public Policy at Georgia Tech. I'll admit that's my alma mater, so great to have you here. She leads the Climate and Energy Policy Lab there, and she's also a member of the Board of Directors of the Tennessee Valley Authority, which is the nation's largest public power provider. Previously, she's had leadership positions at Oak Ridge National Labs, and because of her leadership in analysis and interpretation of the U.S. energy future, she sits on the National Academy's Board of Energy and Environmental Systems. So Marilyn, we're delighted to have you here. Then to build on Cheryl and Marilyn's comments, we have C3E Ambassador Alla Weinstein, who has actually done this job of moving technology into the marketplace. So she comes from the perspective of someone in industry. She's the CEO of Principal Power, as Amy mentioned. She's had extensive experience working with industries like Honeywell and Boeing, doing projects for them. And she's going to bring that perspective of somebody who's actually done this deployment. So Alla, welcome to the panel. And then finally, once technology is market ready, we've overcome regulatory and policy issues, then we need to get it deployed on the grid. And that requires special attention to energy systems integration issues. And we're pleased to have Renata Mele here from the Enel Foundation. She's an expert in renewable energy strategies and how to incorporate those into the grid. The Enel Foundation itself has as a goal to carry out research, training, and outreach on socioeconomic impacts of energy and sustainable development. Enel is Italy's largest power company and the second largest utility in Europe. Renata, thank you for being with us. So with that, I'd like to kick off the panel presentations. We're going to have brief remarks from each one of the panelists on those different aspects of moving game-changing technology into the market, and then we'll have a period of discussion amongst the panelists. We'll open it up for Q&A with you, and then we'll close with a few comments. So Cheryl?
Thank you very much. Somewhere here. All right. I'm really glad to be here this morning. I actually graduated from MIT with my PhD in chemistry, and it's been a long time since I'd been on campus, so to walk through it certainly had a lot of changes, lots of building still going on. You know, ARPA-E, how many of you know about ARPA-E? All right, well, you guys don't need this presentation then. All right, so you'll have to indulge me though. I'll talk really fast and give everybody else time. So ARPA-E is all about the development and deployment of early stage energy technologies. And our mission is so big you could drive a truck through it, right? We're all about, we can do anything in energy as long as it reduces energy imports, improves efficiency, and reduces emissions. That's a pretty broad mandate. So it really comes down to how are you going to do that? And ARPA-E's model, we are not about doing science, and we're not about doing true learning curve development, so the applied programs in the Department of Energy. So, but we sit in that in-between translational place. How do we take, science, where maybe the I's are just dotted and the T's are still a little bit wet, and get it to a point that somebody else is going to step in with next stage investment? And so our projects tend to be 3 years long. We have a model of, is there a pointer on this thing? Possibly, where our program directors come in, identify a white space. White spaces in energy, problems are pretty well known. When we talk about white space, we really mean parsing a problem in a way that nobody's ever done it before, to draw new eyes, new people to the problem, and change the constraints. So if we've been battling cellulosic biofuels, why fight millions of years of plant evolution? Why not just genetically engineer them to look more like fuel in the first place? So can you picture tappable pine trees, where you get terpenes at levels at which you could think about just tapping it off? Could you put the genetic characteristics of algae into tobacco and actually have big oil and big tobacco save the world, right? So it would truly be, right? Those are the types of ideas where you move the constraint. It doesn't mean that we don't have to worry about, well, suppose you got those pine trees, what would happen in a forest fire? But that's a different constraint. So that's what we do on a regular basis. Those are the conversations we have in the office. Once we've created a program, and select the projects, which yesterday we just announced $66 million for 33 projects across 18 states, doing biological conversion of nat gas for fuels, and also metal processing. If you're going to talk about things like lightweighting of vehicles and you're going to replace steel, well, the metals you replace them with, titanium, magnesium, aluminum, really should have a better life cycle than the thing you're replacing, or you're falsely thinking that you've done something. So we do things like that. And then we manage them, and it's very active. If you get an ARPA-E grant, we are in your pocket there every quarter. You love us or hate us, but we're there with you. But the cool thing about our model, I think, is beyond just creating these really, really crazy out there goals. Well, one is some of the technology actually works. But the really cool thing is, at the same time, we focus on tech to market. So you get a 3-year grant from ARPA-E, we say on day 1, well, what's going to happen at month 37? How are you going to get this to the next phase? And usually grantees look at you like, you're just giving me $3 million. What are you talking about? I want to do this work. But we all know it doesn't go well if you don't plan in advance, right? If you're going to license your technology at the end of 3 years, well, what do you have to do beforehand? When do you have to have the licensees? What do you have to know about the market? So we spend a whole lot of time, and several of the members of the team, Sue's here, Casey's here, Brenda's here, a couple of our interns from the summer are here. We spend a lot of time with folks talking about what are the markets you're in, right? If you're going to disrupt something, you better darn well know how it works today, right? Is there value? Who has the value? Who defines the value? And oftentimes those aren't the same things, right? What kind of techno-economic model is appropriate for you? We're working on widgets. Well, the widget's got to be a thing, especially if it's going to be on the grid or in the transportation infrastructure. It's a large problem. How are we going to define, what's appropriate for costs at the same time? Right? It's energy, right? We got to focus on costs at the same time as we're transforming things. Skills and resources, we worry a lot about that with our folks as well. Half of our awardees are academics, a third are small companies, only about 20% are large companies or national labs. So folks who aren't used to translating their science into something, right? They don't, we talk, it's not a comfortable place. We got a lot of very, very smart people working on energy technology. They're not comfortable not knowing and thinking about market. They don't, it feels like they're going to give up what they do well in order to think about that. But we work with them to say, how do you, I joke about it, how do you know enough French to cross Paris, right? I don't need you to be fluent. I don't need you to write the next treatise in French. Just get enough language so you can talk to your next stage partners. Well, how do you understand licensing agreements? So we run things like webinars and training things for folks. And we also do stakeholder engagement. Well, who matters? Who matters from today to the future if you're going to be on the grid? Who are the regulators? Who are the customers? Who are the manufacturers? How do you understand that? And how are you going to get to know those people over the next 3 years? Right? This is, the reason you all are here today is to form networks that can leverage what everybody wants to move forward in clean energy. We do the same thing with every one of our awardees. So all 285 projects with ARPA-E have a tech-to-market plan that talks about how are they going to get to market. So we use the term all the time, if it works, will it matter? And so the if it works is the science. Will it matter is ultimately all the rest of this. And so it's a really, really unique piece of our model, one that I'm really excited about. I came from 20 years in industry, and this is how it works, right? And so how do we bring this together? And so it's really exciting. The miracles happen all the time when you knock down innovation in the face of a real need, and people are really willing to take it forward. And so I'll finish with just my last slide, though. It's like, okay, well, this sounds all exciting, and you're 4.5 years old, ARPA-E, and punching above your weight. But well, what do you do? How do you think about success? What's it going to look like? Well, someday, when we're as old as DARPA, so 50, we will have the Internet of Energy. I'm absolutely convinced. But until then, we need some metrics if we're going to continue to get money from Congress. So working from the bottom up, operational excellence, we do take it very, very seriously that we are using the taxpayers' money to leverage to this great future. So we work a lot to make sure we're using it efficiently. We do focus on, technological breakthroughs, world records, patents, and publications. But the reality is, if all ARPA-E gets is those first two things here, we have failed, because we won't have fulfilled the deployment part of our mission. And so we look at moving the technology towards the market. What are the handoffs that happen? And if you think about energy, there's a number of them, right? It's not, lots and lots of energy things are going to not be venturable, right? They're just not, the model doesn't fit. So things like partnership with other government agencies, going to scale. If you're carbon capture, right? You can't go from the lab to a power plant in one leap. That's probably not prudent. So how do we demonstrate those things? How do we work with like Nettle and Fossil Energy and DOE to do some of those? How do we work with Mongstad in Norway to do some of those things? New company formation. We've had 12 companies form from technologies that we have funded. How do we help those companies move forward? Establish company partnerships and licensing. I think to what the rest of the panel is going to speak about. Everyone from GE, UTRC, ConocoPhillips, people stepping in, DuPont, to actually partner with companies in many, many ways to be part of project teams. And we do measure follow-on funding. There are places where that's appropriate. So we've seen 17 companies, we funded $70 million, gained over $450 million in follow-on funding. And so again, all signs that we're starting to build this tapestry of transformational energy and hopefully forming new communities, of which I hope that throughout meeting, with you today and hopefully some of the team, we can network into your future as well, because it takes, certainly is a thing that takes a village. Thank you.
Oh, thanks. Well, it's a pleasure to be here at the second annual C3E conference, and wanted to especially thank MIT for hosting us once again. I'm at Georgia Tech, and we do have C3E Envy, hoping to host one of these days soon. So keep it, look for that in the future. I wanted to talk about the worries that I have in my research program and in my teaching, which is how are we going to energize industrialized economies and pull about 1 billion people out of poverty without overheating the climate? Now, obviously, we're going to need new technologies, new scientific breakthroughs. We're going to have to transform our current energy system to one that emits or avoids emitting greenhouse gases. But you can also argue that we have a lot of the solutions already in hand, and the problem is that they're not making their way into the marketplace. So there is a need to better understand the techno-economic marketing issues, as Cheryl emphasized. We do have, relative to more constrained markets around the world, markets here that are fairly adept at absorbing new technologies driven by market forces and a fairly unconstrained and dynamic consumer market. But still, there are structural barriers that inhibit progress. One of those that I am up against all the time is the regulations that public utility commissions use to reward their utilities, the return on equity being a function of sales. Now, some states have fixed that, but a majority of states have not. And so if you're not selling electricity or natural gas, your shareholders are going to be penalized. So why would you promote an energy efficiency program or promote distributed generation if you're not going to be able to get a profit in the meantime? So let's see. One of the ways that we can work on accelerating getting innovations into the marketplace is to, in addition to getting rid of those structural, regulatory, and other barriers, we can work on the demand side and try to better understand how consumers make decisions. So just as an illustration, we know that there's a lot of imperfect, incomplete, and inequitable information out there that promotes this boundedly rational decision making. People only have so much time to try to pull together the decisions on how they'll spend their scarce resources. So policy analysts have, over the past 4 or 5 years, kind of shifted much of their attention from looking at problems of the, sort of, we used to point to the industrial titans, the oil barons and the utility CEOs as the biggest part of the problem. But in a sense, you could argue now today, consumers are a big part of the problem. And if we can get them to demand clean and green energy choices in the marketplace, then the market will be more responsive. We're recognizing that a great deal of the choices made in the energy economy are made by consumers. We vote with our 2 feet in shopping malls, in auto dealerships, and in the voting booth, of course. But so this valley of death, which people like to point to as one of the problems in getting innovations into the marketplace, can be addressed to some extent by helping to create market demand for clean energy. And one way to do that, in addition to addressing the barriers, is to look at the flip side of the coin, and that is to look at those policies that can help tackle the barriers and the failures in the marketplace to allow it to operate more efficiently and to promote the development of this market pull. This diagram shows a policy supply curve. It's a little bit like the McKinsey technology supply curve, but it's asking the question, how much could an intervention on the policy side bring electricity efficiency into the marketplace? So looking at various regulatory subsidies and information programs, some of the widest bars on that chart, meaning some of the biggest and most impactful policies, are those that deal with information, benchmarking how buildings perform, requiring that they post information about their energy consumption at the time of sale or rent, for instance. So just as one example of a very successful policy intervention that helped to catapult better refrigerators into the marketplace, in part by dealing with the demand side, is the refrigerator story, right? So back after the Arab oil embargo in the mid-1970s, your household refrigerator required about 2,000 kilowatt hours a year to operate. And now codes, appliance standards, and labeling have brought that down through a combination of research, providing the technology opportunities to operate a refrigerator more efficiently, better compressors, better insulation, better controls and motors, but in combination with periodic requirements for minimum performance standards and labels. So we have many successes that have approached the notion of pulling technologies into the marketplace with very creative systems, solutions, combining research and policy. We have, for instance, the new US lighting standards combined with new labels. We've got our renewable portfolio standards and investment tax credits that are making such a difference in the solar markets. And of course, the latest round of vehicle standards are all transformational. So in order to keep that up, it's going to take all of us to provide effective system solutions that combine this technology and market policy and barriers and behavioral issues. Gender parity at our universities, national laboratories, boardrooms, and legislatures are going to be essential, is going to be essential, because it's going to take all of us to transform our energy systems and heal the planet. Thank you.
Good morning. I guess my presentation, well, no, I'll go back here. Good morning, it's a pleasure to be here. I hope I'll try to merge together a bit the prior two speakers, what they were talking about. I'm Alla Weinstein. This is my second startup venture. It's called Principal Power, and it's looking at the offshore wind, not just offshore wind, but floating offshore wind. There are only two installations in the world. One is done by us, where a small Seattle startup does very strange things, not software, but very large hardware. And Statoil, a very large Norwegian oil company. Two structures have been in operation for over 2 years. We've been in the water for 2 years. They've been in the water for 3 years. And we're both generating and producing energy into the grid. At the time when we started, ARPA-E didn't exist. So we couldn't really turn to our maybe incubator to try to help us out. So we had to go and find the location in the world, literally, where we could do what we wanted to do, which is demonstrate our technology. This is what the industry uses today. Very, very large structure. These are the foundations put in the ocean floor. They're banked in, they're connected somehow to the ocean floor, but they're very large. If you look on the bottom there we go, that's Persian. So you can see the sizes of the structures, and you can see the impacts that they may provide. And then we have very large boats. In order for installations to be put together, you need supply chain, and those boats cost a lot of money. They are not available, and they really are the bottleneck of the whole industry. So what we wanted to do is eliminate all that, and in addition to that, reduce cost. As you move into the deeper ocean, the cost of the foundations becomes very large, which translates into a large cost of energy. So after about 40-meter depth, you cannot really put anything fixed on the ocean floor because you're going to be limited by these boats that have legs that put on the ocean floor and by these structures that just cannot be done. So what we did is we looked at floating structures. So in fact, we did eliminate everything. And we did go from a wave tank testing in Berkeley to the much larger wave tank called the Atlantic Ocean. and installed our wind float in November of 2011. It took us 30 months to get from here to there. It was very fast. We would have fit into your 3-year program, but with a little bit of a challenge. But we had to go outside the country. We could not do it in the United States because programs were not available. And what was also missing, and actually still missing, is the market. The market pool that we so desperately need is pretty hard to find. And so you have to look at around the world. If you want to get your innovation into the market, you cannot be limited by one place or one country. So here is the wind float as it was fabricated in Portugal in 2011. As you can see, it's all, what you will see, it's all assembled on shore. A major difference between fixed foundations that have to be installed offshore and something like this is you do everything onshore. So you would minimize a lot of offshore work. The turbine was installed onshore, and once it's installed, it can be all commissioned onshore, which again simplifies cost, reduces cost, simplifies work, and reduces a lot of risk. We were in very shallow waters, and so we had to use the energy of the tides to help us to propel out of the dry dock, which is why it's at 4 o'clock in the morning when the tides happen to have. But then we also had to deal with a very narrow sandbank, and yes, we had to get through it very fast with the tide. Once we got into the open ocean, you can see we only used one small boat to tag the unit to the installation site. It traveled 400 kilometers from the southern port of Portugal to the north and has been installed 5 kilometers offshore in northern Portugal. It has been operational since then, and as of a few days ago, delivered 6.5 gigawatt hours to the grid in Portugal. It's using Vestas 2 megawatt V80 turbine. What's interesting, we did not change the turbine at all. We took it right off the production line, put it on the floating structure, and demonstrated that we do not, but actually improve performance of the turbine. So where do we go from here? Well, we demonstrated in the wave tank, we demonstrated in a bigger wave tank. Now we're producing, now we're at the energy level. What do you next? If you remember Cheryl's chart, you now need to figure out where your market is. Well, the market is a challenge. Why? Because of the cost of energy. And the cost of energy on the first installation is going to be high. So we were very successful at the end of last year of attracting government funding in both United States and in UK and in Europe. And at this point, we're doing front-end engineering design for 3 projects, one in the United States, in Oregon, one in Portugal, in a different location, but a little bit further north, and another one in UK. All of those would be with a larger turbine. We're going for 5 to 8 megawatt units, because that's when your economies of scale kick in, and all of them would be in about 30 megawatt size, because that's a good pre-commercial size plant. So in Oregon, we're looking at Oregon. Why Oregon? If you look at the map of the United States and you see the colors, the darker the color, the more resource and wind energy resource you have. So this particular location has the best wind resource, and it also happens to have good infrastructure like a deep water port and things like that. So we're looking at doing a 30 megawatt installation around Coos Bay in Oregon. Fabrication will take place on the West Coast, probably between Oregon and California. And if all goes right, we will be the winners of the next budget period, and we'll actually do the implementation of this project. But you can see that we're using a lot of partners. Technology is great and wonderful, but unless you can figure out how to put it in the market, it's going to be just that, great and wonderful technology. So it takes a lot of people, and as somebody said, it takes a village to get there, or maybe a country, or maybe the world for that matter. So it's what you don't see in this picture that really matters. There is no big cranes, there is no big boats, there is no big foundation. It's just one wind float and one small boat. And that's what it takes to make it happen. Thank you.
Thank you. And I'm very pleased to be here. I'm Renata Mele from the Enel Foundation. And for those of you who don't know Enel Foundation, it is a very small research center recently established by the Enel Group. That is, as Rob said before, the second largest utility in Europe and utility based in Italy. We have a presence as Enel Group in 40 countries. And the Enel Foundation is a no-profit entity, and our aim is basically to develop research and study in the field of energy, socioeconomics, sustainable development, and innovation. And I wish to bring your attention to a more general perspective on the field of the clean tech development, because we think, and everybody in this room knows, that we are undergoing, the energy world is undergoing a deep transformation. And this transformation is basically driven by global challenges. I wish just to remind everybody knows that climate change is one of the first points to be addressed by the transformation of the energy world. We know that the world is on a trajectory that is consistent with the increase in the temperature, in the world temperature, and without new aggressive policies, the risk and of an even more dangerous track is real, is consistent. Growing energy demand, we know that yesterday it was reminded that we are facing the request for the growing of the energy demand coming from the developing world, and that is a huge demand. 1.3 billion of people now are still lacking the access to electricity. And the energy security, of course, providing reliable, stable, and sustainable energy at affordable prices. Those are the three pillars we know very well of the energy trilemma. And I remind here because those pillars are basically the key point that driven at the moment the renewable energy development. And in the last decade, we know that it has been an important growing of the renewable energy and of the distributed generation. The two things are growing together. And we know that this development has been strongly non-uniform, for instance. Here I reported the example of the solar PV capacity because it's an important example of both renewable energy and distributed generation. And what we know, and it's very well known, that the solar photovoltaic capacity has been growing in the last year very deeply, reaching up to 70 gigawatts of installed capacity around worldwide. And in this scenario, what we know here is reported the top 5 countries developing and installing solar PV capacity. And it's clear that there is a strong effort that's been devoted to this development by some countries. That is an effort driven by the policies, and we will see later. Germany, Italy, and Spain reach up to the 60% of the worldwide installed capacity of solar PV. And an important growth has been also for the other renewables energies. But the growing of distributed generation lead also another important point, that is growing of the energy provided through the network by these unintermittent sources. And we know that, just as an example, I reported here the distributed generation provided by solar PV in sunny days last year in Germany that reached up to the 50% of the energy demand. This is a very important point because it means that it has a reflected consequence on the overall network and on the overall system, on the overall electric system. And this is just to address the point of the high renewable sources penetration in the electric system and impact on the grid. We know that there are many drivers, we saw many drivers to the development of renewable sources. basically, as I mentioned before, the 2020 objectives, that means the European policies, are representing a large share of the reasons for the development of the clean technologies, but also the increasing of environmental awareness and increasing of fuel prices. But there are also many barriers we have to overcome to providing and to fostering the development of renewable sources. And first, economics. Everybody knows that without an appropriate policy structure, without appropriate subsidies, some of the renewable sources cannot be fostered appropriately. We need economic support for that. An important barrier is represented by the uneven legal and regulatory framework. Development of renewables, so clean tech, requires an harmonious and stable and integrated regulatory framework. Political and social acceptance, this is a common problem for all the large infrastructure, and impact on grid stability. And is the impact on grid stability that I wish to bring to your attention, because this is the point that has to grow in parallel with the clean technology development. It's part of the growing of the clean technology development, because growing the share of the intermittent sources in the grid needs to rethink the electric system to be transformed from a centralized network strictly controlled by the utility, to a grid with a diffused intelligence, the so-called smart grid, that embrace distributed resources and that can implement new functionalities. The grid of the future, what is named, has to implement new functionalities and has to provide solutions basically for managing the energy flows and the renewable integration. And here we can see how can be considered, how can be redesigned and transformed the electric sector, starting from the grid. We have to transform the traditional grid that has centralized management and unidirectional power flux to a fully integrated smart grid that allows both centralized power plant, because diversification is one of the key points for the energy security, and it means that distributed generation has to be coupled to centralized power generation provided by fuel and conventional sources. And distributed fuel power generation that can be different technologies and needs a kind of different integration, so coupling with storage systems, coupled both to the network and to the single generator, and connection to industrial and residential. And getting this transformation of the electric system means to ensure grid reliability, quality, and security, and from the side of the network, but also to provide and to allow active demand and to have an active participation of the end user to the consumer and to the consumer of energy. And this can be done only enabling monitoring, single house monitoring and interaction. And this is a very important point, active demand and impact on the social, on the use of energy and on the interaction of the people that can directly monitor and control the consumer of energy is one of the key issues to increase energy efficiency at the level of the end user. And without this involvement of the people, of the population, of the single user in the energy efficiency, the important goal we have behind cannot be reached. Thank you so much.
Thank you all. Those were great presentations, a lot of food for thought in those. I'm mindful of a couple of things. One is the time, and also is the desire, I think, to get discussion with the audience on these. So what I'd like to do is start with a couple of questions here with the panel, and then open it up for discussion with the group at large. So I'd like to start with a question maybe aimed primarily at Cheryl and Alla, looking at this question of engagement between government and private industry. Cheryl talked a lot about the ARPA-E's early involvement in stimulating work that's probably too early for the private sector. And yet to get it deployed, we need to have the private sector involved. And so maybe, Cheryl, you could start off talking about how you do engage the private sector. And then Alla could talk a bit about maybe what you wish you had seen when you started. You mentioned you predated ARPA-E, but talk a little bit about what would have really helped from your point of view.
Okay.
Yeah, I think the ARPA-E model, it can be particularly impactful because when we run a program area, so be it batteries or carbon capture or fuels, because we're running $30 million, 15 projects, we can leverage that critical mass to bring together on an annual basis our awardees, and at that same time to say, who do they need to know? So if you need, like if you're going to do seed production, fuel production, you need to know the seed guys, you need to know the conversion people, and potentially the funders, right? The venture or other types of large funders. And so we can bring those people together right from the very beginning of a project. And so over 3 years, the group gets to know each other. The industry itself actually gets to see how the technologies are developing. The technologists themselves get to know people. And again, why does business happen? It happens because you have relationships with folks, and they don't develop overnight. And so I think one of the big things about what ARPA-E is trying to do is right from the beginning is leverage, a reach to the industry, including partners on our projects. Like I talked about half of our academics as prime, but most of them have subs that are industry people as well. So I think that both of those pieces really plays very strongly to being able to move this forward quickly. So I don't know if you had that early on, if it might have accelerated some of it. But I think there's still a valley of death.
Oh, no question about it. We're not out of the valley of death yet. We are hoping that we'll cross it, but we're not there yet. You're absolutely correct. It takes a big knowledge base, and whom you know becomes very, very important. Investors don't always look at the risks. They don't want to invest in something that will not bring the investment or the return on the investment. So I heard that many times from just about every investor. If the government doesn't invest, I don't want to invest either. So this early stage participation of any government you want to take becomes extremely, extremely important. The reason why we were able to do what we did, and the reason why we were able to find and secure $30 million that it took to put this device in the water is because of the people that I happen to know from my first venture, which was a little bit more exotic. It was wave energy conversion. But spending 10 years and kind of knowing the world and knowing what is available where, that allowed us to be able to find partners that were willing to step in and put this money in without much of the government participation. However, if ARPA-E would have existed when we started, it would have helped a lot on preserving more portion of the company for those that created the company. Because as you go through the process and you bring in investors, and when you're looking for the amount of money that you need to put something like that in reality, it takes, your company becomes smaller and smaller for what's left for those that created it. So it's a balance that you want to strike, but at the same time, what's most important is to see the technology in reality. It really doesn't do anybody any good to have great inventions sitting in the closets. They just don't do anything there.
Thank you. Let me shift to the policy side a bit. This addressed to Marilyn and Renata. Renata spoke a lot about issues in Europe, integration of renewables into the grid. I'd like to address the question to the two of you. What do you see as differences in the policies needed to move renewables onto the grid, to get those deployed in Europe versus the US or other parts of the world?
Okay, I can start.
with a general consideration that is related to the fact that there is an important difference in the policies that are now active in both areas, in Europe and the United States. In Europe, as I said before, the 2020 is a commitment. Mm-hmm. It means 20% of renewables up to the 2020. And this commitment is taken seriously, but it is in Europe, but it requires a huge economic effort. And it means that at the end of 2000, it means 2007, 2006, it has been an important growing in the share of subsidies devoted to the development of renewables. And this important share has been reducing at the beginning of 2012 and 2013. So we are now reducing in Europe, in Germany, and in other countries in Europe, the level of subsidies for that, because it is considered that the level we had before, it was unsustainable. Even in this changed framework, the level of subsidies for fostering the development of renewables is very high. But this is a level of subsidies related to the development of the single and clean technologies. The development of the system integration and of the smart grid has been also really pushed ahead through the program of metering that has been already established in some countries in Europe. I wish to mention the case of Italy because we have 31 million of smart meters already installed in a program that started 15 years ago. And also in other countries in Europe, so it is reached the share of 40 million of meters. But this is all only a small part of the smart grid. And there is no incentive subsidies program at the moment standing in Europe for fostering the development of the smart grid. The level of investment required is very high, and we have a lot of research program, but there is no subsidies for that, and this is an open issue. On the other hand, from the US side, the level of incentives is very low and is really uneven. Is, as you very well know, but maybe Cheryl, she knows very better than me, it's uneven in the country. And so the problem of the system integration is at a different level. It's at the level of the single states. Among the states, there is need for different kind of integration. And also the uneven level of subsidies can be an issue to be overcome. But the overall policy-driven engagement for the fostering the renewables is completely different from the two sides of the ocean.
So I noted at least 4 issues that are in play in those states of the United States which do not have a renewable portfolio standard. So when there's no requirement, there's no goal, the utilities are just operating freely in the marketplace, there are still barriers. First, there's the avoided cost test. So renewables, solar in particular, have trouble with meeting grid parity and competing head-to-head if you don't fully value the benefits that they can deliver. So there's a whole issue now raging in the solar marketplace about the value of solar. How do you value it? You really have to ask, can it compete at the cost of an avoided kilowatt-hour bought wholesale markets on the grid? And then there's the issue of decoupling. I mentioned that in my few remarks, that utilities, if they don't own and aren't generating the electricity themselves, they don't get this return on investment or return on equity. And so there's a built-in resistance to promoting renewables or distributed generation. And then there's the issue of net metering. So there's some states that have, or utilities, actually net metering in most states is passed by the legislature. So it is a state policy that directs their utilities. And the utilities are given limits to how much electricity can be bought back at a retail rate. And in many states, this limit is very low. So for instance, in some states, it's still in the kilowatt range, even for industrial and commercial customers, which doesn't make any sense at all. And then there's the Territorial Act. So that's the last on my list. The Territorial Act in traditionally regulated states prevents a third party from generating electricity and using the grid to sell it to consumers or to customers. Only the designated utility who's been given the monopoly right to a particular territory is allowed to do that. So that's 4 things, and I think if I had another minute, I could have doubled the list. But thank you for such a good question. We are very different from the European setup. Yeah.
Okay. So let me at this point open it up to the audience and see if we have questions.
Okay. Hello. Thanks to each of you for bringing some very valued perspective to the table. As I listened to each of you, I was reminded of a different variant to this conversation, which is often simplified in public discourse to say, should government be choosing winners? And I know we don't need to convince this group that all this clean energy work is very valuable, but I'm wondering, in sort of thinking of this from sort of a macro level, how do you think we need to sort of change the broader public discourse on this?
If I may start from looking at how to get new generation in place for new technologies, it's really the market driven. It helps a lot to have European model. It helps a lot to have a framework that creates a demand through those that can pull technologies into place. Not having it in US is a very, very difficult situation because there is no reason. It's like Marilyn said, you know, why would they bother? And every discussion with utility kind of comes to, why should I? Why should I pay more for putting something new in place? Even though you can get through all the people you know and all the partners you can, if there is no market, you can't get there.
When I think from ARPA-E's perspective, you know, our job is about creating options, right? We're all about creating options because the reality is that we face an uncertain energy future. No one of us knows, or at least if you do, I hope you have a really good job leveraging that knowledge, where energy is going to be in the future. And so having lived through way too many energy cycles in the past, you know, I don't know if we know what nat gas will be doing in the future. We don't know what the issues are going to be. We don't know what the opportunities are going to be. We don't know what kind of natural or man-made disasters are going to befall us as we change the grid and we set it up as micro, macro, renewables, whatever you're going to set up, there are going to be challenges in the future. That's all we know. And so I think the whole idea of there is a place in that uncertainty, separate from risk, but uncertainty, to say that you absolutely need to be creating developed options to have choices. So separate from the market pull exactly and what role government could play in that, but at least from our perspective, it's a really, really important thing because that uncertainty is very, very real.
Can I also comment, such a great question, and we talk about it all the time in public policy. So for a policy to be not picking winners specifically, it needs to instead categorize the nature of the benefit or goal that's being sought, and it justifies the public intervention. And so rather than picking specific winners, for instance, in the lighting standard, it requires a certain luminous efficacy, or lighting efficiency, the goal being to provide lighting fixtures that can provide light with less electricity consumption. So you're not, people say, oh, this is the incandescent bulb blowout or whatever. This was not a law that said you can't produce incandescent bulbs. If you could produce them at that level of efficiency, then they also could compete in the marketplace. It set a goal, and all those options able to meet that goal are allowed in the marketplace. So those kinds of discussions over what are we trying to achieve, I think are really worthy of more debate. What is the goal behind the policies that we see?
Mm-hmm. Really great discussion. So the good news here is that We've had lots of interesting observations and comments. We could go on all day.
Yeah.
The bad news is we just got the hook. So I'd like to thank our panelists for really great observations. I'd like to also throw out to you in the audience the question of what innovative methods, techniques have you observed or witnessed or practiced in your own careers for moving game-changing technologies into the marketplace? Take those ideas, if you would, and share them with the group on C3E Net. Great opportunity for us to continue the dialogue, even though we're out of time here. We can keep this going later today and in the future. So thank you again. This was just a great discussion.
Thank you.
Thank you.